just as fast as my feet can fly. Come away if you're going. Leave the sinking ship behind. Come on, rising wind. We're going around the bend. Bring a soul and a smile for the banjo. Better get while the getting's good. It's a ride at the end of the highway where the neon turns to wood. Come on, rising wind. We're going around the bend. You can phone to perpetual emotion. Get your mind on a crystal day. All this time for good conversation. Doesn't have fall for what you say. Come on, rising wind. We're going around the bend.
Hello, and welcome to the 35th video of this little series we have get going. And the featured movie of the week is none other than Freebirds. And the reason I kind of recommended Freebirds to watch is because, well, if you notice the date, it is kind of close to a famous holiday called Thanksgiving. And in Thanksgiving, we eat, turkeys. So I kind of drew that comparison there. This movie is kind of about surrounding Thanksgiving theme. So that's kind of why I pushed this forward, because we are nearing that holiday. And after next week's video, expect to see a lot of Christmas-themed movies. And, sorry, I literally just lost where I was going. But just about the Christmas movies, they're going to be recommended. All sorts of holiday type movies will be recommended. Just beware. But not next week. Next week will be just a normal movie. The rest, I'll just throw some holiday stuff at you. So without further ado, our topic. And I was saying our video introduction to long division. Sorry, I had to step out for a second, but I kind of came back. Hopefully I didn't lose track of where I was. To you, it kind of didn't seem that way, but I just had to pause and play it. So, introduction to long division. So, what we have been doing is 20 divided by 4, and we're like, that equals 5. But we're not doing any actual math. So, we're going to finally be doing math. So just how addition, in order to do the math, let's take 13 and 3. For multiplication, addition, subtraction, and multiplication, we write it like this. So what do you think we write for division? It's exactly right, guys. We put a 3 over here, a little bracket like that, and then the 13 inside. That's how you write it for division. So all of these are kind of the same, but once we get to division, everything changes. So we're gonna be I'm just gonna practice you for 2 minutes on how to actually figure which number goes inside here, which number goes out there, and then we're gonna finally do the math. So if I wrote 13 divided by 3, the second number goes on the outside, and I draw my bracket, and then the first number goes on the inside. Or I could just draw my bracket, put the first number in the inside, and then the second number on the outside, whichever one you want. So I'm going to give you some examples, and then I'm going to pause myself for maybe around 5 seconds. But please do not solve these, because 57 divided by 8 cannot be solved unless you know a certain thing or two that we are not on yet. But I just want you to rearrange these in the order that we discussed, like the, whoops, that is not how we're supposed to write it. You write a little parenthesis, and then you just draw a line, like the 13 and 3. Draw it like that. So turn it from that to that. Now I'm going to pause myself, play back the video in order to refresh your memory, but let's go. Okay, so first thing I like to do is I just like to draw my little thingy. It's definitely a name for this, but my mind is just not remembering the name right now. So, first number goes inside, second number goes outside. Same thing. Just like that. Second number goes on the outside, first number goes on the inside. Now, we see this big number. Think something's going to change? Absolutely not. Nothing changes. The size of the number has zero effect on where we put them. 36, second number goes on the outside. This big number goes over here. So now you figured out how to redraw them. So this video is going to be focused on having a single digit as the second number, so not a double digit or more than that, so don't worry about how to solve that. So let me give you an easy sample problem to solve. 2 divided by 20. Okay, so when I say 2 divided by 20, what happens? If I just wrote it like this, because this is how it originally looks, correct? You'd say 10. So the way we do this and the way people like to start out is they say, okay, let's take this number and that number. They say, what number? So basically people put their numbers up here. That's where you're going to find your answer. They're going to have a question mark, question mark, question mark, da 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 da. As many digits in your answer as possible. So they're going to say, we need a number here, we're going to need a number here, so forth. So what number multiplies with 2 and gets you 2? Exactly. 1. 1 times 2 equals 2. So these are the same. Now you know what we do? We subtract. And 2 minus 2 is 0. We bring the 0 down. So now we bring the second number down. So the next number that we're working with, which is the 0, we bring it down over here. So now, what number times 2 gets you 0? 0. 0 times 2 is a 0. 0 minus 0 is 0. Perfect. That means we have no numbers left. So when you're done with your subtraction, in this kind of division, you are going to have a 0. Now there might be an instance where you have a 3 and you can't keep going because you ran out of numbers to drop down over here. And that is what we call a remainder. However, please do not worry about that. That's like 2 videos from now. So let's go through another example. So if I said a 4, and we're just going to do a very long number. Hopefully, let me see if this works. Okay, 4 over here will work. Perfect. All right, first thing we were doing, we got to put a number over here. We always got to start. 4 times what number would give me 8? Perfect. 2. So 4 times 2 is 8. Minus 8, you get 0. We have to bring down the next number. 4 times what will get me 4? 1. So minus 4 times 1 is 4. 0. Bring down the 2. Now, what times 4 gets you 2? Aha! You guys are stuck. Now, this, when there's no number where you can multiply it, you have to find the lowest. You have to. So, when you reach this, you have to say, okay, what number times 4, what product of them would be less than this number? That's what you have to think. So what number times 4 would give you something less than 2? That is 0. 0. So you get 2. Bring down the 4. 24. What number times 4 is 24? 6. 24. And you get 0 at the end as usual. Now, that is what I like to call a piece of cake. But, okay. Yeah. So you always have to end up as a 0 for now. So if you're doing the worksheets and practice problems and you're not having a 0, you're not ending with a 0, then something is a bit off. Now, just because of this, probably some of you at the beginning were like, whoa, Nadav, that's a really, really, really big number. That's in 8,000. I don't know how to deal with an 8,000. Well, you do now. That's why we are finally using math to make it much easier. We just made a big number seem like a very, very small number. And that's the whole point of long division. This method over here is called long division. So let's go through another problem. We're going to make a big number a smaller number. Okay. Alright, seems fair. So, what number times 7 gets you 6? Exactly, nothing. So now we have to think, well, what number times 7 gives us something that is less than 6? 0. 0 times 7 gives you 0, which is less than 6. So we have to bring down the 6, bring down the next number, because we have 6 minus 0, so that's why we have the 6 down here, and then we bring down the next number, because now we have to work with this place value. So, what number times 7 gets us 63? Exactly, 9. I don't even know why I drew that line, but 63 minus 63, 0, perfect. Now we bring down a 9. Now, what number times 7 equals 9? Exactly. There's no actual number or a whole number that can be multiplied with 7 and get you 9. So now we have to think, what number times 7 would give you the closest answer that is lower than 9? It would be 1. Now some of you were like, well, hey, 0 times 7 is 0, and 0 is less than 9. So why can't I just do 0 times 7? Well, the thing is, I said the closest lowest number. So 7 times 0 is 0. 7 times 1 is 7. 7 times 2 is 14. 14 is over 9. Which one of these is closest to 9? 7, exactly. So that's why we use 7. When you can't multiply to get a perfect number like the 63, if you can't match that perfectly and you become like a 7 and 9 case, you have to find the number that would multiply with the number over here that would give you an answer that is lower, both lower and the closest. So 7 minus 9 is 2. Bring down the 26. So now we have to do it again. What number times 7 gives you 26? Exactly, nothing. So we are at a little trouble again. However, what is the number that is lower, both lower than 26 and is closest to 26 out of all the possible combinations with 7? And you would say, well, 7 times 1 is 7, 7 times 2 is 14, 7 times 3 is 21, and 7 times 4 is 28. 28 is over 26. Can't be that. 7 times 3 is 21, which is the closest. So it's 7 times 3. 21, you would get a 5. You would have to bring down the 6. And this actually works out perfectly because 8 times 7 is 56. And you get a nice whopping 0 as your final. And since you got a 0, this has to be the answer. Now I just want to bring you back to this example. I'm going to give you a little trick to solve these problems really, really fast. When we were thinking in our heads, we said 7 times 2 is 14. 7 times 3 is 21. 7 times 4 is 28. Now, the first number that passes 26, which is 28, the number before that is always going to be your answer. So 7 times 9. 7 times 1 is 7. 7 times 2 is 14. 14 passes 9, and it's the first one that passes 9. It's the first product that passes 9. So the one before that has to be the answer. So I'm going to do one more, and then I'm going to leave you guys on your, own. So 9, 4, 8, 9, 3, 3. Now, remember, this is a single digit. We might have more in the future on this side, but for now, we only have 1. So, 4, 0. We can't because 9 times 1 is 9. So, the only way we could go is 0. Minus 0. Bring down the 4. Bring down the 8. And just so you know, just to be organized, you should always be drawing your arrows to indicate when you're bringing a number down. So, 9 times something could be 48? No. So, let me think. 9 times 5 is 45. So I'm just thinking of numbers that multiplied with 9. I'm just thinking of numbers that 9 can multiply to that are near 48. Like 45 is near 48. 54 is near 48. So these two are both near 48, right? So when I see a number that can't be actually perfectly multiplied, I'm like, okay, what are the numbers that are close to it and around it that can be multiplied with the number with 9? Just 45 and 54. 54 does not work. Since 54 is actually the first number that cannot work, we must go to 45. What number times 9 is 40? 45? It's 5. So, perfect. 3. Bring down the 9. We are at the same problem again. So now you're kind of around getting the hang of just saying, hey, all right, I have a 39. The closest lower number that is multiplied with 9 that is near 39 is, 36. Which is 9 times 4. And 3. I'm going to bring this one down. Again, we are at the same problem. And the nearest number that's there is 27, which is a 3. I get a 6. Bring down a 3. God bless. That finally works perfectly because a number times 9 can actually make 63, and that is 7. And we do end up with 0 at the end. So at the end, it will always be perfect. But that is your answer, 5,437. Now you will definitely not be able to do that in your heads, I guarantee you, but with this little long division, you will be able to at least solve it. Not in your heads, but on paper. But so this little thing that we were doing, do the practice worksheets, try the games, work on that like thinking. Now I know I did these last two kind of fast, but that was just on timing and I did not want to make this video drag any longer, but this is really a really hard topic. Introduction to division. I might be doing another video on this just to solidify it and make you refer back to my original video of worksheets and stuff. But that's just a debate within my head. So these yeah, I did these kind of fast, and that's just doing practice problems. The more I did, the more I was be able to say, hey, 36 is the closest to it. So remember, when a number cannot have, when a number multiplied by 9 can't get you that number, you have to find the next best number that is closest to it and also lower than it. So in these cases, 39 had 36 that was closest to it, 33 had 27. Because I knew in my head already 9 could give me these three numbers. These four numbers, and 45 if you want to say. So I was like, hey, 39, that has to be the closest and lower one than that. For 33, it cannot be 36, it has to be 27 then. For 48, it could be 36, but it's not the closest because 45 is the closest. So that's kind of my thought process going into those questions. But I know this is a really hard topic and some of you are still just like so confused. Please rewatch the video, try to understand it in and out really thoroughly. Just try to do some of the worksheets. Next week's video is just going to be a little introduction to remainders. We're not even going to be doing this anymore, so I'm going to drop this for a week and then bring it back the week after to help you solidify any of your problems. So really, please do not stress over this. We will figure this out in 2 weeks. But if I'm seeing that I really do need to make a second video for this, I will make a second video for this. But alright guys, hope you enjoyed this little video here. Stay safe, stay cool, and stay learning. Bye-bye.